Lesson 2, Unit 5. 5. 5? Yeah. 5. We are dividing polynomials. We're going to start with long division, and then we're also going to learn the shortcut method for using synthetic division. It's going to be great, grand, and glorious, except sometimes you have to use fractions in that one, so, scary. But you'll be fine. I almost promise. So let's dive into using long division. We're going to jump in with an example. This first one is a little bit simpler. We have in this particular example, you're like, that's simple? That's as simple? What is happening? What is happening? Sad day at Black Rock. I don't know. Anyway, yeah, this one is actually simpler, and I'm going to show you why. Because right here, we've got a trinomial on the top. So it's got 1, 2, 3 terms. But then we have a monomial on the bottom. So when we have something like this, where we have a monomial, a polynomial of any size divided by a monomial, so just one term, it's really easy because all you do is divide each term by this thing. And you're just going to use those same exponent rules we talked about in the last lesson. So for the coefficient in the front, you just divide. So 6 divided by 3 is 2, right? And then we've got like base to divide x. So the fourth divided by x is x cubed. Y squared divided by y is just y, right? Easy peasy. Next one, 12 divided by 3 is 4. So we get plus 4. X cubed divided by x is x squared. Y squared divided by y is just a y. Y to the first. We can leave that off when it's the first. Same as this one over here. Negative 18 divided by 3 is negative 6. X squared divided by x is x. And then y divided by y is y to the 0 or just 1. So it actually just cancels there. So that's easy when we got a monomial on the bottom. But what if we have a binomial on the bottom? So this time we're dividing this trinomial by this binomial. So we're going to start out by doing this just like we learned long division. I'm going to kind of do a mini example, and I'm going to kind of show you and remind you how to do long division, because I know it's been a few years. It's Algebra 2 at this point, so it's been several years since you were in middle school having to do this kind of stuff by hand. So little micro example, if I was taking and I was doing 3 divided into 2,331, then excuse me, I would do 3 goes into 2, no times, right? So we don't put anything there. 3 goes into 23, 7 times. Then what do, right? So it goes into that 7 times. Then you multiply these two. So 7 times 3 is 21. Y'all remember doing this? What do you do next? You subtract, right? So subtract. And why am I doing this? Because it's actually going to be the same thing over here. I'll show you in a second. 23 minus 21 is 2. Then what do you do after you subtract? Well, you bring down the next one. Bring down that one. 3 goes into 23. How many times? 7 times. 7 times 3 is 21. Subtract it. Is 2. We bring down. Oh, dang it. I didn't mean to make something. I want this to have a remainder over here. So let's make this a 2. Sounds good. A 2. Bring down a 2. 3 goes into 22. 7 times. Not a fun number. 21. Now we've got a remainder of 1. Now, if I want, the last thing I want to talk about that's going to transfer and translate over to this example is, this will be 777 remainder 1. If I want to write a remainder as a fraction, y'all remember how to do that? I hope so. You put this as the denominator and then this as the numerator. So this little micro example, 2,322 divided by 3 is 777 and 1/3. Let's take that rememoration of things and apply it over here. So we're going to start by just writing this in this form. So in middle school, I like to talk about is which one's on the porch and which one is in the house. The first one always goes in the house, and the second one always goes on the porch. The bottom one goes on the porch. So we're going to put x minus 5 on the porch, and x squared plus 3x minus 40. Okay, so just a side note, when you're setting up one of these problems, we'll see this later on a synthetic division problem, we have to write both of these in descending order, and it needs to include all of the terms. So like, say we had a 4th degree polynomial. So x to the 4th plus x cubed. Actually, that's fine. X squared plus 1, right? It has to include everything. So it has to include a 4, a 3, a 2, a 1, and a 0, right? So if I was to put this one into there, I would have to write it as x to the 4th plus 0x cubed plus x squared plus 0x plus 1. So if there are any missing, you want to add this 0 times the missing one. We'll leave that as a note for other examples and future problems and all of those things. All right, let's continue to tackle this one. So see, it's in descending order, 2, 1, 0, 1, 0, right? So the first step is the same thing. Remember, we go see how many times this goes into that. How many times does x go into x squared? Well, x squared divided by x is x. So it goes into it x times. The next step after we did that was to multiply. We're going to do the same thing, but you have to multiply it times both things, so you're going to distribute. So x times x is x squared. X times negative 5 is negative 5x. What did we do next? We subtracted. Well, we're going to do the same thing. We're going to subtract, but we're going to do it with a binomial, so we have to flip both of these signs. So we're going to change this one to a minus and this one to a plus, which will let us subtract. X squared minus x cancels, which is what you want it to do. If it didn't do that, you did something wrong. Double check what you've done. So 3x plus 5x is 8x. So after you subtract, you bring down the next thing. So we're going to do the exact same thing. We're going to bring down the next thing, which is a minus 40. And then rinse and repeat until we're at the end of the line. So x goes into 8x 8 times. So plus 8. Then distribute. 8 times x is 8x. 8 times negative 5 is negative 40. Look, this one's going to come out pretty with no remainder. Right? So we're going to subtract, which means flipping both the signs, this one and that one. These cancel, which is what we want and expect. This also cancels, which is not always going to happen. We get a remainder of 0, which means the answer to this problem is x plus 8. That's easy peasy. Let's do another one that's a little bit weirder. Okay, so now this one's cheeky, right? This one is, it's kind of written in a different way. It's x cubed, excuse me, a cubed plus 2a squared plus 4a minus 9 times 2 minus a to the negative 1. Well, what is something to the negative 1? Well, it changes levels, so it's still division. It's just kind of a cheeky way of writing it. You'll see this in your textbooks and all those things quite often. So we're going to do this the same thing. Now, I'm going to write the bit on the porch. I'm going to kind of move it around because remember, what did I say? It has to be in descending order. So I'm going to switch it into descending order. Now, for long division, the number in front, the coefficient of to the first term can be different than 1, right? So this can be negative 1, it can be 5, it can be 3, it can be 888. It can be anything there. It could be fractions, whatever else, right? That's possible. When we get to synthetic division here in a couple minutes, it can't be, right? So I'm just rewriting this, but in descending order. So I'm putting the a term first, and then I'm going to write this one in the house. So a cubed plus 2a squared plus 4a minus 9. I got a little bit wild with my house. Extra rooms. So negative a goes into a cubed negative a squared times. Negative a squared times negative a is positive a cubed. Negative a squared times 2 is negative 2a squared. Then we're going to subtract. Flip both signs. Those cancel. That's what we want. That's what we're hoping for. 2 plus 2 is, of course, 4. So this is 4a squared. Next is to bring down the next thing. So plus 4a. Now we're going back in here. Negative a. Negative a goes into 4a squared negative 4a times. Then we distribute. Negative 4a times negative a is positive 4a squared. These should match. If they don't match, you did it wrong. Double check what you're doing. Negative 4a times 2 is negative 8a. Then we're going to subtract, which means flipping both signs. That cancels. Great. 4a plus 8a is 12a. We're going to bring down our 9, or our minus 9, I mean. Minus 9. And then negative a goes into 12a, negative 12 times. And then we distribute. So negative 12 times negative a is positive 12a. Negative 12 times positive 2 is negative 24. We subtract, which means flipping both signs. That cancels. Negative 9 plus 24 is 15. So we're at the end of the row. So now we're at the remainder zone. So we like to write, when we do these division of polynomials, we like to write our remainder as a fraction. So remember what we do to write as a fraction. If we go back to wrong thing, this one, what we did was we put this one over that one. We're going to do the same thing over here. So it's going to be plus a fraction. In the numerator, it's going to be 15. And then because it's going to look prettier, I'm going to put 2 minus a right there. That's the same as this, just rewritten with the negative in the middle. You could do that either way, right? And that's it for that one. Let's do another one. This one's going to look scarier, but it's actually going to be easier than it looks. If it's the one I'm remembering, yes. Okay, so we've got a 4-term polynomial, 4-term third degree polynomial divided by a trinomial. 1, 2, 3. Oh no, it's a trinomial in the denominator. Don't stress. It's like I say, it looks scary, but this one's actually kind of easier than the other ones that we just did. I'll show you. All right, so we're going to put the bottom one on the porch. X squared minus 5x plus 6. This one in the house, x cubed minus 2x squared minus 9x plus 18. So we do the same thing, right? So x squared goes into x cubed x times, right? Because x cubed over x squared, we subtract the exponents. 3 minus 2 is 1, right? So then we're going to distribute. X times x cubed, x times x squared is x cubed. 1 plus 2 is 3. They match. That's a good sign, right? X times negative 5x is negative 5x squared. And x times 6 is plus 6x. Weird smell down here. I don't know. Something strange. I don't know. Don't know what's happening. It's fine. Probably won't die. If I pass out on the video, maybe somebody will still get it out to you. All right. Change all the signs. Right? So that cancels. Negative 2x squared plus 5x is 3x squared. Negative 9x plus negative 6x is negative 15x. That's easy peasy so far. So x squared goes into 3x squared 3 times. X squared and x squared going to cancel. So plus 3 and distribute. 3 times x squared is 3x squared. 3 times negative 15 is, oh, I forgot to bring down the next thing. Oops. Why didn't you remind me? How dare you? 3 times negative 5x is negative 15x. Ooh, look, that's going to cancel. That's fun. 3 times 6 is plus. Oh, it's all going to cancel. That's great. Flip, flip, flip. Cancel, cancel, cancel. Leaves it with 0, so there's no remainder. If there was a remainder on one of the problem with a trinomial in the denominator, in the divisor, or is it the dividend? I don't know. Divisor, dividend. I don't remember. I think it's in the dividend. I don't know. If there was, you'd do it the same way. You'd put this in the denominator and this in the numerator. Easy peasy. But this one is good to go. How about synthetic division? So let's look at a shortcut, which is good because here pretty soon we're going to divide a whole bunch of polynomials or the same polynomial with a few numbers switched a bunch of times. So we want a shortcut, all of those things. So let's take a look at an example using synthetic division. So we just looked at long division. So for synthetic division, we're going to start different. We're going to start instead of with a house and a porch, we're going to downsize and we're just going to have a cardboard box. We're going to make it easy. We're going to downsize to a tiny house. On the front here, now if the a of the bottom number is or the bottom polynomial is 1, then we're good to go. We don't have to do anything fancy at the beginning. All we do is we take this number and we flip its sign and we write him here. So instead of -4, we're going to write a +4. Now, why do we flip the sign? I'm going to tell you that because that might help you remember what's going on. We flip his sign because that's going to take care of the subtraction part. So now what we're going to do is we're going to write down all of the coefficients without the x's. And if there's one missing, like I talked about before, you got to put a 0 in its place. Actually, our last example in a minute is going to have that as something that happens. So we're going to do 2, -13, 26, and -24. Then we're going to kind of leave a little space. I'm going to put a line under the whole schmagoigle. All right, step number 1 is now that we're actually going to do the division, first step is to just take this one and write him down right there. He's just going to come straight down. The first one's easy peasy. So we're going to write down 2. Now, we're going to take and do 4 times 2. And we're going to put that up here. 4 times 2. Now, in long division, we subtract, right? We took care of the subtraction by doing this. So instead of subtracting, we're going to add. So -13 plus 8 is -5, right? Easy peasy, lemon squeezy. We're going to multiply. 4 times -5 is -20. And then we're going to add. 26 plus -20 is 6. 4 times 6 is 24. Add them. -24 plus 24 is 0. That means it's going to have a 0 remainder. Now, the last thing we got to do is we got to turn this back into a regular polynomial, and it's going to look like this. I'm going to write it, and then let's see if you can figure out what's happening. So it's going to be 2x squared minus 5x plus 6. What do? We just took these numbers, and the exponents was 1 less than this. Easy peasy. So instead of being a third degree polynomial, it's a second degree polynomial. So 2, 1, 0. There's no remainder because we got a 0, so there's not plus any thing over here. Easy peasy. Let's do one more and see what you think. I don't know that I've ever said this before, and this is a scary one to do this on. But, when we do two or more examples of that are kind of the same sort of thing, it's a decent idea for you when you're taking these notes to try it on your own with pencil or whatever, or even on scratch paper, or at least think through it on your own before I do it, instead of just copying what I'm doing. That's a good way to engage with material. So this one is an uh-oh, because there's two things happening that are a problem. One is this A on the porch part is not 1. That's a problem. We need it to be 1. Second problem is there's no x to the 0 term. That one we know what to do. We're going to add a 0 at the end. Easy peasy. This is a little less easy peasy. We need this to be 1. How can we turn a 3 into a 1? Well, we can divide by 3. And if we divide by 3, we got to divide everything by 3. Oh no, fractions. You're going to be okay. It's going to be all right. Fractions are just numbers. It's okay. So we're going to synthetically divide. I'm going to go ahead and rewrite this whole thing. You could probably go straight from here to your cardboard shack and run and gun and go, or your tiny house. That probably is better than the cardboard shack. I don't know. Your tiny house, right? But I'm going to go ahead and rewrite this. So 3 divided by 3 is 1. So this first one is x to the 4th minus 5 thirds x cubed plus 1/3 x squared plus 7 thirds x. And I'm going to go ahead and add plus 0 here as well, because that's the missing bit, just to make sure that we have consistency and get the right things and put the things in the right place. Divided by x, just 1x, right? Plus 1/3. Now we're all set and we're good to go. Let's make our tiny house. Here's our tiny house. We're going to put negative 1/3. You got to remember to flip that sign on that one, because that takes care of the subtraction. Now we're going to list our numbers. There's nothing there, so it's just a 1. And then negative 5/3. So no. At least they all have the same denominator. It's going to be okay. You're going to be fine. And then 1/3, and then 7/3, and then 0. Oh, that's nice. Zeros are fun, because 0 times anything is 0. All right. Going to start by bringing the first one down. 1. Negative 1/3 times 1 is negative 1/3. Easy money. Then you're going to add. So negative 5/3 plus negative 1/3 is negative 6/3. That does equal 2. Since we got stuff, actually, no, I'm not even going to do that. Let's forget that. No. Negative 6/3 is negative 2. Negative 1/3 times positive. No. I can do this. We can do this together if we only believe, or something. Negative 1/3 times negative 2 is positive 2/3. I don't even know what I'm writing anymore. 1/3 plus 2/3 is 1. Wow. Negative 1/3 times 1 is negative 1/3. 7/3 plus negative 1/3 is 6/3, which is 2. Negative 1/3 times 2 is negative 2/3. Yeah, sorry. I was making sure I was sanity check, because that's going to come out to a fun ending to this problem. 0 plus negative 2/3 is negative 2/3. So we're going to rewrite this as x cubed, 1x cubed. 4 minus 1 is 3, right? Minus 2x squared plus 1x plus 2 plus, we got a remainder this time. So we got a fraction. Negative 2/3 over. We can write it as this one or this one for now. I think I'm going to write it as this one. You'll see why I'm going to leave it as kind of ugly for now. It's going to make it easier to unugly it in a minute, because we've got to unugly it. Because we can't be done. Because we can't leave this ugly compound fraction. This is technically the answer, right? But it's not simplified. It's not as simple as it goes. So let's take this and deal with him. So let me make me kind of a a little pocket of fraction dealing. All right, so we've got negative 2/3. 2, struggling with my 2. Negative 2/3 over x plus a third. Let's take x plus a third and make it and get common denominator here. Let's make this all one fraction. So if I wanted x to be over 3, I could multiply it times 3 over 3, right? Because that's 1, right? So that could turn into 3x over 3 plus 1/3. Now that we've got a common denominator, we just add the numerators. So 3x plus 1, and the denominator stays the same, so 3, right? We're going a lot back to middle school in this particular lesson. One of the reasons why, well, no, we won't go there. So this denominator, we turn into this. We turn it into 3x plus 1 over 3. Now, we've got a fraction divided by a fraction. How do you divide fractions? Do you remember? Well, let me help you. Since, there's no feedback through the lens. Cameras can't talk. At least that one can't. In order to divide fractions, we multiply by the reciprocal. So this turns into negative 2/3 times the reciprocal of this, which would be 3 over 3x plus 1. We can do some pre-reducing. This 3 and 3 reduce, right, to 1 and 1. So it turns into negative 2 times 1 and 1 times 3x plus 1, right? So I think we can go to the final brain cell or countdown or something, some final something here. Squared plus x plus 2 plus negative 2 over 3x plus 1. You could go one step further. I can't remember. What does our book do? Does it? Yeah. So it's probably a better idea to kind of go one step further and to pull this negative out to the front. I think that's going to be our best look for this answer. And that's it for this lesson. We'll see you in the next one, in which we do something else with polynomials. I think polynomial functions, with probably graphing and stuff. So, see you later. Hope it's been a good one. Bye-bye.